Hello. This is the last lesson of our topic. This is probably going to be the last video that we record for 7th grade science. Congrats on making it. I'm sad about it. I'm going to miss you all so much, and I'm so proud of you. Again, I can't say it enough, but let's get started on light. Okay, so there's 3 different types of materials that light can either absorb or reflect or be transmit, so be passed through. So there's 3 different types. There's transparent, there's translucent, and there's opaque. So you might have heard of these words before, but let's explain them. Transparent is where light can pass through easily, okay? And you can see through it clearly. So like a window, like this piece of glass right here. These are all transparent things. Then there's translucent. It could kind of pass through, but also some of it gets absorbed. So it scatters the light and passes through it, so you just see a blurred image. You might see a stained glass. That is a type of translucent glass. Or sometimes people have showers that have translucent windows on it, so you don't see the person showering, right? So that is translucent. Then there's opaque. That's reflecting or absorbing the light that light strikes it. So the material is either being absorbing that light or it's reflecting that light. So for instance, you can't see it. You can't see through it. So I am opaque. You can't see through me. You are opaque. I can't see through you. This can is opaque. Nothing is being seen through. So again, transparent, you could see through it clearly. Translucent, you could kind of see through it. You could see objects, but it's kind of blurry. And then opaque, that is, you can't see through it at all. Okay. So again, with light, opaque is the wavelengths being absorbed completely. You can't see through it. Translucent, some of the waves are being passed through, but some are being absorbed, so you can kind of see through it, kind of not. And then transparent, you could fully see through it. All of the light is being passed through. Okay, next, let's talk about color of the objects. So how do we get color? So color is what is being reflected off of the light. So white light is made of all different colors of the rainbow. When we have, for say, the red shirt right here, this red shirt is reflecting the red light, so it shows that we could see that red, and the rest of the light, so the orange, the yellow, the green, the blue, the violet, the indigo, all of those are being absorbed into that shirt. So we only see light that's reflected. So if we see something green, that green thing is reflecting the green light. If we see something pink, that is reflecting pink light. So a mix of all those different colors. Okay. So again, it's just the reflection is what we see in terms of color. Okay. So the color, again, of an opaque object is the color that it reflects. All other colors are absorbed. Okay. White objects, so if I have something white, I have this right here, it's kind of white. This is reflecting all colors. And then black, the shirt I'm wearing, is absorbing all colors. Okay, so we can't see any of those colors. White, it's reflecting all of these colors, so it comes out white. Black, it's absorbing all the colors. Think about paint. So if you put all the colors of paint all together, it kind of looks like gunky, kind of darker black. That's absorbing. Okay. The color of a transparent or a translucent objects, because those two things can be colorful, that's the color of a light that passes through it. Okay. So the light that passes through maybe a piece of cellophane that it shows in this picture. If the cellophane is green, you're going to only see the green light. Okay. Next, let's talk about color filters. These are really cool. These types of filters can change the color of an object. You could see this sometimes people who are into photography have color filters on their camera. So this one is a purple color filter. It only shows that purple color. The rest of the light is being absorbed into the filter. Okay, so it changes the color of an object. The red filter, so if this was red, a red filter allows red light to go through. So the red objects or anything that's red looks red, and anything else looks black. So it looks black because there's no light to reflect back, so we don't see any other colors. Okay. Now let's talk about reflecting light. So there's two different types of reflections. There's a regular reflection, so that is like a mirror. That's a parallel ray, so it's going parallel all together. It hits a smooth surface and it reflects at the same angle to create a clear image. Okay, so it's not all different angles, it's reflecting at the same angle that it hit. Okay, and it creates a clear image. A diffused reflection, it's when parallel rays hit uneven surfaces like a lake and reflect at many different angles. So all of those rays are going all over the place. They're not all together. So again, an instance is a reflection off of a wavy lake. Wow. A reflection off of a wavy lake. Sorry. Those rays that are hitting the lake are going all over the place. So it's not really reflecting a clear image. Okay. So now that we know about different types of reflections, let's talk about mirrors. A mirror is just where light can be reflected to form images. So this dog is seeing its reflection, and that is because of a mirror. First, let's talk about a plane mirror. That's what we know most. So when you look in like a bathroom mirror or just a straight up and down mirror, that is a plane mirror. You see a virtual image, so we know we're not inside that mirror, right? So that means it's virtual, it's not real. And the image is upright, and it's the same size. So we're the same size as when we look into a mirror, but our left and our right are reversed. So have you ever seen someone be like, oh, I look totally different in a camera versus in a mirror? That's because the left and the right sides are reversed, and maybe they're not totally symmetrical. Okay. So a plane mirror, it's upright and it's the same size, but the left and the right sides are reversed. Okay. Then there is a convex mirror. Convex mirrors are mirrors that curve outward. So for instance, like the outside of a shiny bowl. If you look at a shiny bowl on the outside, your face might look a lot smaller than it actually is. Okay, that's because in convex mirrors, that's when images appear smaller. There's also convex mirrors in like side view mirrors of cars. That's why it says objects in mirrors are closer than they appear, because the image appears smaller, meaning that it will look farther away because it's smaller, when in reality it's not. Okay. Next is a concave mirror. A concave mirror curves inward, so the opposite of a convex. So it's caving inward. And this creates a larger upright virtual image. So this picture accurately depicts that. She's showing her hand, and it's a much bigger hand in the mirror. Or depending on where an object is in the mirror, or when it's shown in a mirror, it can create an inverted, so an upside down real image, depending on the placement. So if we look further into this picture right here, we kind of see that the bench is upside down. That is showing that inverted real image. It all depends on how close or how far away you are to the concave mirror. Okay. And again, the difference between a concave and a convex. Convex is, it shows like a bowl, and concave, it kind of looks like a skateboard park, right? Like a ramp, if you would. Okay, next is lenses. A lens is a curved piece of glass that refracts. Refracts means bending, and it bends light. Okay, so a lens is a curved piece of glass that refracts light. Okay, so there's, again, two different types, concave and convex. Convex lenses are thicker in the middle and thinner at the edges. So again, it's kind of doing the same thing, but it's a lens, you could see through it. A mirror, you can't see through it. Okay. So as light passes through the convex lens, it refracts, it bends towards the center of the lens. If there's a bigger curve in the convex lens, there's more bending. So if the object is far away, it's going to produce a real large image. Okay, so you might see these at like bubble things at an aquarium. That is a convex lens. Those fish are not actually that big. They just look like it because of these lenses. And also a magnifying lens that is a convex lens, and it makes the real larger image. Okay. If an object is closer to that lens, it's going to produce a virtual image, which means that it's not really there. Okay. Next is concave lenses. Concave means that there's thinner in the middle and thicker at the edges. Okay. So it's thinner in the middle and thicker at the edges. And as light passes through the concave lenses, it refracts or bends away from the center of the lens, which forms an upright, and it forms a smaller image. Okay, so in this picture right here, that is a concave lens. As you can see, this part of the bench is closer than the actual image of the bench in the concave lens. That's because it's producing a smaller image, making it look further away. Another instance of a concave lens is a peephole. So when you look in a peephole, people look a lot smaller than they actually are, right? So that's because of that concave lens. All right, that's all I had for this light lesson. Your last video. I will miss you, and I hope you learned something new, and I will see you in class. Okay? Have a good rest of your day.